All right, you guys, here is the final lecture for our electrical modalities module. I completely recognize that this was probably information overload, right, you guys? Yes, you're all shaking your head as you're listening to this online lecture. So what I wanted to do before we move into the final modalities of this class is really just provide kind of a conclusion for electrical modalities, to provide a synopsis of all of the modalities that we've learned in the electrical modalities module. So I hope this is helpful for you to kind of put everything together and start looking at it more from a clinical perspective versus I need to know this to take the lab practical or the actual exam. So when we think about electrical modalities, where we're going to start first is with the parameters. I think that's a key component, is looking at the actual parameters, right? Because the parameters, what they do is they allow us, or they tell us exactly what we need to know, or what we need to manipulate, in other words, to create a physiological response, right? So the first parameter that either can or cannot be manipulated is frequency. We're thinking about the machine frequency. This is something that cannot be manipulated. This is something that the manufacturer determines, the mechanical engineer determines, but it certainly isn't something that we as clinicians can manipulate. So what we know about machine frequency is that the best devices are those that are capable of delivering a high frequency or delivering a high voltage to a patient without causing injury, right? Or without having contraindications. So if you are an athletic trainer who's thinking about running your own clinic and you're thinking about purchasing an electrical stimulation device, the machine frequency is certainly an important parameter that you need to consider when you're thinking about the outcomes or patient outcomes. But what can be manipulated most often is the frequency for the treatment, right? And the treatment frequency, believe it or not, you guys, is what's responsible for creating the physiological responses that we see in our patients when we apply an electrical modality, right? So I'm sitting here getting pumped, even though you can't see me, because it's this parameter, this treatment frequency parameter, that dictates what's going to happen with our patient as long as everything else is set up correctly. This is otherwise known as the pulses per second, or the hertz of the treatment, or the volts of the treatment, depending on which electrical modality you're using. It's also what the patient may feel. And so it's most often considered like your pins and needles, or your discrete muscle pumping, right? Or in other words, it's 60 to 120 pulses per second, or 2 to 4 pulses per second, right? That is the treatment frequency. So when you walk it to a patient and you get ready to treat them, you have to be thinking, what is the goal? And then based on that, I'm going to manipulate my treatment frequency such that it would cause a physiological response that I want it to cause. And we'll talk about specific modalities and specific treatment frequencies, but these are just the parameters. Our next parameter is the duty cycle. The duty cycle represents the amount of on and off time of the electrical stimulation. Most often that's associated with high volt, biphasic, and in Russian. It's because these three modalities are typically going to be used in muscle re-education. Now, of course, I have listed high volt in the muscle re-ed section, but I've said that most often, typically, we're not using high volt for muscle re-education. That most often we're using our biphasic and our Russian stim, but this duty cycle certainly is something that can be manipulated in the high volt electrical stimulation. So just something to keep in mind. What we know about the duty cycle in particular is that it's the cornerstone of muscle re-education. So the duty cycle is going to be important to creating strength gains after post-op or after surgery, after lengthy immobilization, right? So the duty cycle is something we want to manipulate if the goal is to improve strength gains following surgical intervention, following long immobilization. Our next stop is in the area of polarity. Most often, most machines will have a negative polarity selection, a positive, or they could have what's called an alternating polarity, where it alternates back and forth between negative and positive. With our negative polarity, we most often use this for chronic pain and to impede edema via edema formation. So early on in the acute phase of an injury, most often they're going to put on a negative high volt treatment to hopefully stop edema from forming. I was going to use reduce, but that's not the correct term. Our positive polarity, however, is used for acute pain, but then also used to reduce edema that's already there. Does that make sense? So the edema is already present. So you put on this positive polarity and hopefully it repels out that edema. So this is something that we use when we already have edema present again. And then we can use this alternating. It's very rare that we use this in the clinical setting, but most often when we have that patient who's in between, there looks like there's edema, but you want to prevent more from forming, so you want to reduce it, right? So you do this alternating kind of selection for the parameters of polarity, right? Polarity is extremely important when we're thinking about edema. Certainly can be utilized to reduce pain, but we have modalities that are better served that don't have a polarity associated with them to attack a painful patient. The last parameter that I want to talk about is intensity. The intensity is what the patient's going to feel, right? The frequency is what the patient is going to feel in terms of the rate, but the intensity is actually the feeling of electrical stimulation. So we really have 4 goal intensities, right? The first one is subsensory, so they won't feel it at all. We'll push on the intensity, we'll turn on the device, but most often that patient should not feel this treatment. Most often, most subsensory treatments are going to be utilized in fracture healing. We'll talk about that when we get to specific modalities. On the sensory side of things, this is just when the patient can actually feel it. Most oftentimes, this is used in pain control treatments, specifically the gate control theory of pain. You have motor, which means you actually want to see a motor response, right? I know I just had you guys for lab, and one of the things that I saw is when you put the muscle re-ed stem on and we got the motor contraction, one of the things that you didn't do is have the patient contract, but the motor is simply stating that we want to see a motor response. We want to see a visible motor or muscle contraction. The last form of intensity is noxious, and so this is going to be that painful stim, most often associated with trying to attack the central biasing theory. But again, we don't typically use that very often in the clinical setting. So now, with all of that said, we've talked about parameters. I think it's important to talk about the different types of stim. And yes, I know this chart is a mess, but it's how you guys said, just spill it out for us, Dr. Cosby. So I'm doing that for you guys in real life, right? So let's start with high volt first. High volt is best used to deal with a patient who has edema, right? We've talked about the different types of uses. So it could be used to prevent formation, or it could be used to reduce what's already there. If we're using high volt and we're thinking we want to deal with edema, if we're trying to prevent edema from forming, then we have to have a high frequency, and we should be utilizing the negative polarity. And last but not least, we want that treatment to be 30 minutes and at least 4 times a day, right? So that's a long time that patient's going to be with us, and that's okay. If, however, the patient already has edema, we certainly can still use high volt, but we need to change some parameters. 2 parameters in particular. The frequency of the treatment changes to 2 to 4 pulses per second. And that makes sense to you guys because that 2 to 4 pulses per second, or that lower frequency treatment, is going to cause muscle pumping, which is going to do what? It's going to facilitate that lymph system. Finally, we have to adjust the polarity to a positive polarity if we're working on reducing edema within our patients. Okay, so that's high volt for you. Very simple, I think, but takes a little bit of a learning curve. Our next group of modalities are what I call the pain-reducing modalities, and that would be TENS, IFC, and PREMOD. For TENS, I really like the portability of it, right? It's extremely portable. Patient can take it home, wear it all the time if they so choose to do so. So I really like the portable nature of it. The reality is, though, it's not a powerful device. So when we think about frequency spectrum of the actual device itself, it's very low on that spectrum because it's powered by a very small battery, right? So for those reasons, it has its limitations. But certainly what we do know is it's capable of reducing pain in patients. In fact, it was one of the very first pain-reducing electrical stimulation devices created on the market. So we have to give it its props, its homage, right? So if we're thinking gate control, and this applies for TINS, IFC, and pre-mod. We want the frequency to be high, so between 60 to 120 pulses per second, or even higher than that. We want a 20-minute treatment, right? If we're thinking endorphin release, then we want the frequency to be relatively low, and we want the same treatment time, about 20 minutes, right, you guys? Same thing with IFC and pre-mod. The biggest differential is this device itself is powered through the wall, so it's capable of delivering higher machine frequency, which means it's capable of delivering higher hertz over time. And so this is why it's more advantageous. What it also means is we get less tissue resistance because it's delivered at a higher machine frequency, right? Major differences between IFC and pre-mod. This is a quadrupolar setup where you must have the X setup, and then pre-mod is a bipolar setup, right? So most often we're going to be using that pre-mod for your small treatment sites and your IFC for your larger treatment sites, making sure not to cross the spine. Okay, you guys, so we're not crossing the spine with our IFC treatment. I was extremely proud of you guys in your lab practicals because none of you crossed the spine. You chose pre-mod instead of IFC. So kudos to all of you. Finally, we have our muscle reeducation electrical modalities. Electrical modalities. We'll save micro for its own segment. There's Russian and there's biphasic. Certainly your textbook also lists high volt. I just know that these two are the most commonly used modalities for muscle reeducation. As alluded to, you have a duty cycle that you must manipulate, and this becomes extremely important when you're determining the outcome or the strength gains for that particular patient. The other thing that's a key component is the frequency. So most often we've had low or we've had high, and now we're saying that it's probably a medium treatment frequency, right? So about 30 to 80 pulses per second. I would argue that you need to be upwards of that 80 pulses per second to get that tetany, right? Want to get that tetany if the goal is to cause muscular contraction. We certainly need to make sure that we have a motor response. So we need to see the muscle contracting, and then we want that patient to be contracting with that electrical stimulation, right? Now, there is some debate on when these two should be used and which one's the best one. You guys, I can only tell you what I know from the research literature and what's suggested based on the phases of healing. So in terms of biphasic, it's the more comfortable waveform. And so for those reasons, it's suggested that it's best to use in the acute and the early proliferation phases. And then we progress to Russian, which is a more uncomfortable waveform. It's more uncomfortable for your patient. So we progress to Russian in late proliferation and maturation phase, right, you guys? So these are just things that I'm telling you. Certainly you can manipulate any of these. But I suggest using these parameters. If you kind of memorize these, then guess what, you guys? You have the key to pretty much any modality on the market. Finally, we're moving on to micro just briefly. More than likely, you won't ever use this in the clinical setting, but you certainly could. So it at least warrants some talking through. Micro is a subsensory. Remember, we talked about intensity. So this is a subsensory electrical modality, which means that patient is never going to feel it. You can crank it all the way up. They're never going to feel it, right? Most often it's used for bone healing and wound healing, but we're going to focus on bone healing the most. So in terms of intensity, the research suggests taking it up to patient's tolerance. But again, I just said we're not going to feel it. So crank it all the way up. The big key component is that it has a polarity. And so you want to make sure that the negative pad is always closest to the fracture site. It's going to stimulate those osteoblasts to build bone, right? And that the positive is more proximal to, okay? In terms of treatment, the jury's still out on that, you guys. In terms of treatment, what we're looking at is similar to that of high volt for edema reduction. So about 30 minutes per treatment for 4 times daily. Okay, so I really do hope that this is helpful. I know it's a lot to take in, but I really do hope that this is helpful as we end this segment, this very long segment on electrical modalities. I'm incredibly thankful for the ways that you guys rise to the occasion in all of these online courses. Looking forward to our time in the last module of this course.